The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome guys. In this video, we're going to be solving this very problem. And it says we should find the Fourier cosine series of the function. So that's a function defined in its half range. So there's 0 to pi. So it's a half range. So we're going to do this. Since we're asked to find the cosine series, it means we're going to be treating that function, the complete part of it, because it's supposed to be periodic with 2 pi. So since we're finding the cosine series, it means we're going to be treating that as an even function. So as an even function, which will be containing only cosine series, we need only 0th coefficient and a sub n. So that's just the two that we need. So let's find a naught first. So a naught will be 2 over pi integral from 0 to pi of f of x dx. So this will be our a naught. That's our a naught. So this will be 2 over pi, that's our a naught. Now you notice that we're going to be breaking our value down because from 0 to pi, we have 0 to pi over 2 and pi over 2 to pi. So we're going to break this down. So 0 to pi over 2 and then pi over 2 to pi. But I'm going to be skipping the pi over 2 to pi because the function is 0. So even if I say integral of 0, that would be a waste of time. That would be a waste of time. So instead, I'm just going to do 0 to pi over 2 because f of x here was 1 and then dx. Otherwise, I'll be having 0 dx, and 0 dx is just 0. I feel like that's a waste of time. So let's just leave that one out. So this will be 2 over pi. Now, if you integrate 1, you will get x because it's a constant. So you get x from 0 to pi over 2. And then this will be 2 over pi. This will be 2 over pi. Then this x value is going to be taking up the limit. So this will be pi over 2 minus 0. Because anywhere you see x, you should put pi over 2 for the first time. That's the upper limit. Then the second time, you put x as 0. Now, what would then happen? This will be 2 over pi times pi over 2. And everything here will give us 1. So that's our a naught. So a naught is 1. Now, a sub n is 2 over pi integral from 0 to pi of f of x cos nx dx. So that's our a sub n. Now, f of x is 1. That's really reasonable value here. It was 0 at the other time. So this will be 2 over pi integral from 0 to pi over 2 of 1 cos nx dx. That's what we're going to have. Then this will be 2 over pi. Now, if you integrate cos, you kind of know that 1 times anything is that same thing. So if you integrate cosine, the integral of cos is sine. So this will be sine nx from the limit we have is 0 to pi over 2. But do not forget that you have to divide by n. So this is sine nx over n. The n is coming from the derivative of nx. If you differentiate nx, you will get n. So you need to divide by that very n. Now, this n here is a constant, so I can bring it out. So this will become 2 over n pi into sine nx from 0 to pi over 2. Now this will become 2 over n pi. Now anywhere I see x, I'm going to be putting pi over 2. So this is sine n pi over 2 minus, anywhere I see x, I'll be putting 0. So this will be sine 0. Now I already know that this one will give me 0. This one will give us 0. Because sine 0 is 0. But this one behaves in a particular way. This behaves in a particular way. So sine n pi over 2 is equal to, let me put, when n is even, I think that's too far. When n is even, this will give us 0. I've kind of done this before. So when n is even, you'll be having sine n pi over 2 as 0. Next, when n is 1, 5, 9, just like that, sine n pi over 2 will be 1. So when n is in this particular format, it will be 1. Now when n is 3, 7, 11, sine n pi over 2 will give us minus 1. All right, so you kind of get the picture. Now with this, we can be able to just come up with a standard form. If we wish, we can be able to come up with a standard form. But let me keep that somewhere. So this will be 2 over n pi sine n pi over 2. So just keep this. Most persons might prefer to start looking for B1, B2, B3, B4, just like that. It's still going to be the same thing. But I think I can just leave my answer like this for now. Then I'll say Fourier series of this. I'm going to be having a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx. Now the a naught is 1. So this is 1 over 2 plus the sum from n equal to 1 to infinity. Now a sub n is this whole value here. So that's 2 over n pi sine n pi over 2. Then you put your cos nx. That's what we're having. You put your cos nx. Now this is 1 over 2 plus, there's a constant here. This 2 over pi is a constant because the summation is in terms of n. So 2 over pi is a constant, so I can bring it out. So this is 2 over pi. Then we have the sum from n equal to 1 to infinity. What will be left? If the 2 over pi goes away, there will be 1 over n remaining. So this is 1 over n sine n pi over 2 cos nx. Cos nx. All right, now this way we then start putting our values of n. Otherwise, this could have been the answer. So this is 1 over 2 plus 2 over pi. Now let n be 1. Now if n is 1, what's the value of this? If n is 1, this is 1. So everything here is 1. Then this is cos 1x. So this will just be cos x. Because we are putting n as 1. And when we do so, when n is 1, the value of this is 1. So this is 1 times cos 1x. So that's just cos x. Next, when n is 2. When n is 2, this is 0. Because 2 is even. So this is 0. So everything here will be 0. Now when n is 3. When n is 3, you have minus 1. So that means we'll be having minus 1 over n is 3. Then this will be cos 3x. Next value is when n is 4. But 4 is even, so it's gone. So we're going to go to 5. So when n is 5, this is plus 1. So this will be plus 1 over n is 5. So this will be 5. Just like saying that this will be giving us the sign that we need. This sine n pi over 2 will be giving us the sign that we need. Because this is 1, this is minus 1. So sometimes it will be positive, sometimes it will be negative. As you can see here, it was positive, negative, positive. Just like that. So this is 1 over 5 cos 5x. Next will be 6. But when it's 6, it's 0 because 6 is an even number. So let's go to 7. But when it's 7, this sine n pi over 2 is minus 1. So this will now be minus 1 over n. So this is minus 1 over, we're dealing with 7. So this is 7 cosine of 7x. And it follows just like that. Can't really get on to infinity. So that would be the answer to this very problem. So I'll see you in the next one. Thanks for watching.